Hi, welcome to this Park's Geometry class. This is Chapter 2, Reasoning and Proof, Section 1, Inductive Reasoning and Conjecture. Okay, so why are we learning about this? Market research is conducted by an analyst to answer specific questions about products. Research analysts use focus groups to collect data and to look for patterns in the success or failure of a product. The process of using patterns to analyze the effectiveness of a product involves inductive reasoning. Okay, so what is inductive reasoning? Inductive reasoning is reasoning that uses a number of specific examples to arrive at a conclusion. When you assume that an observed pattern will continue, you're applying inductive reasoning. A concluding statement reached using inductive reasoning is called a conjecture. Okay, so patterns and conjecture. Write a conjecture that describes a pattern in each sequence. Then use your conjecture to find the next item in the sequence. Okay. So movie times, the movie show times, you have 8:30 a.m., 9:45 a.m., 11 a.m., 12:15 p.m., and on and on. So look for a pattern. Alright, so between 8:30 and 9:45, it looks like hour and 15 minutes here. 9:45 to 11, hour and 15 minutes. 11 to 12:15, hour and 15 minutes. So based on this pattern, what do you think the next movie time will be? Make a conjecture. The show time is 1 hour and 15 minutes greater than the previous show time. The next show time will be 12:15 plus an hour and a half, which will be at 1:30. Okay. We're not only looking at numbers here, but we're gonna also look at patterns and drawings. So here you have a square. The next one you have, so this one has 1, 2, 3, 4 sides. You have 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Okay, and then the next one. Okay, let's do this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're looking at each stick here. The next one, you had the 10 plus 10, 11, 12, 13, 14, 15. Oops, 15. Whoa. Let's try that again. It's not really clear on this slideshow, but so you had the 10 here, and then this looks like 1, 11, 12, 13, 14, 15, 16, 17, and 18 here. The next one, you have the 18, and then you have 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So it looks like you have 4, 10, 18, 28, 40. So if this continues, what do you think the next figure will look like? Well, it's increasing 6, 8, 10, 12. The next figure will increase by 12 plus 2, because it's just adding 2 more to each increase. So we'll have 14 segments. So you'll have this, and then you'll add 1 more, and then add 14. So 1, 2, and then you'll have 6 on each side. 2, 3, 4, 5, 6. So if you did that perfectly with the measurement with the ruler, then you'll have this figure right here. Alright, so here's your turn, 1A and 1 through 1C. So write a conjecture that describes the pattern in each sequence. That means actually write out and describe to me what the pattern is. Then use your conjecture to find the next item in the sequence. So find what the next one is going to be here, and here, and then here. Okay, so when you're done with these 3 problems, come back when you're done. Okay, welcome back. So here's another example to algebraic and geometric conjectures. Make a conjecture about each value or geometric relationship. List or draw some examples that support your conjecture. The sum of 2 odd numbers. Alright, examples. You have 2 odd numbers, it became a 4. You have another set of odd numbers, you added, you got 6. 3 plus 5, you got 8. 2 odd numbers, you got 16. So is there a pattern? Notice that the sums 4, 6, 8, and 16 are all even numbers. So in conjecture, the sum of two odd numbers will be an even number. Okay, now look at some figures here. Segments joining opposite vertices of a rectangle. Okay, you see all these rectangles and they're meeting at one point. Notice that segments joining opposite vertices of each rectangle appear to have the same measure. Use a ruler or compass to confirm this. So here and here measurements are same. Okay, looks like the measures here, 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 and there are the same. So a conjecture, the segments joining opposite vertices of a rectangle are congruent. Okay, so here's your turn 2A to 2C. Okay, same as we did for the previous example. Make a conjecture about each value or geometric relationship. List or draw some examples that support your conjecture. Okay, here's a real life example. If you are a business owner of a hair salon and they collected data on the number of customers her salon had each Friday, Saturday, Sunday for 6 months to decide whether she should increase the number of stylists working each weekend. The data she collected are shown below. Okay, so each month, Friday, Saturday, Sunday, okay, she collected data on how many customers she had each day. Okay, so based on the data, you make a graph that will display the data we just saw. Okay, so red was Friday, green Saturday, yellow Sunday, and that's the total. Okay. So since you want to look for a pattern over time, use a scatter plot to display the data. Label the horizontal axis with the months, this is horizontal, and the vertical axis with the number of customers. Plot each set of data using a different color and include a legend. That means include this part right here to explain what it is. And then, based on this data, okay, what kind of conjecture can you come up with? So the number of customers on each day usually increases each month, and the total number of customers increases every single month. Survey data supports the conjecture that the amount of business on the weekends has increased, so the owner should schedule more stylists to work on these days. Okay, so it looks like each weekend of each month is increasing, so she should hire some more stylists. Oops. Alright, so here's your turn number 3. So pause the video and go ahead and do number 3. Exactly the same way we did the example together. Then come back when you're done. Alright, welcome back. So we're going to move on to learning about counterexamples. To show that a conjecture is true for all cases, you must prove it. It takes only one false example, however, to show the conjecture is not true. This false example is called a counterexample, and it can be a number, a drawing, or a statement. So a counterexample is one example that proves it false. Okay. Find counterexamples. Find a counterexample to show that the conjecture is false. If n is a real number, then n squared is greater than n. When n is 1, the conjecture is false, because if you have n squared, that's 1, and 1 is not greater than 1. There's one example that makes this false. So that is a counterexample. Okay, here's another one. If jk equals kl, jk equals kl. Okay, so these two lines here. Then k is the midpoint of jl. When kjl are non-collinear, then this is false. If you do have kj or jk and kl, and if it is on the same line and these two lines are equal, then yes, k is the midpoint. But if they're not collinear, if they're not on the same line and k is over here, then this is not true. So here's an example when k is not collinear that would make this false. Okay, so here's your turn, 4A and 4B. So find a counterexample. Give me one example that would make these statements false. And when you're done, that is all the homework for tonight. So make sure you put this away and put it in your book bag for credit tomorrow. Thanks for watching.